Hello everyone, welcome back to Atomic Ascent, the place where chemistry becomes simple, logical, and truly fun. If you are a student preparing for any kind of competitive exam, or you simply want to build a strong command over chemistry concepts, then you are just landed in the right classroom. So grab your notebooks, stay focused, and let's begin our journey of mastering chemistry. So let's get started. Our today's topic is discovery of neutron. So we have already heard about that how the other subatomic particles like electrons or protons have been discovered. So now we are going to talk about discovery of neutron. In 1932, there was a scientist known as Sir James Chadwick. An English scientist he was. So he was actually working on some experiment. Let's talk about that experiment. So he took a very thin beryllium sheet and he bombarded this beryllium sheet with alpha particles. And he observed an unknown radiation that was having very high penetration power. Okay. And when these unknown radiations were made to fall on paraffin wax, they actually help in the production of protons or ejection of protons. Now these protons were then simply counted with the help of Geiger meter. So Geiger meter or Geiger counter is a kind of instrument that actually counts that how much radiations have been emitted. He observed that these unknown radiations, which were having high penetration, had no charge on them. So they did not show any kind of deflection in electric or magnetic field as earlier subatomic particles, which were electrons and protons, showed. So it was neutral. He also found out that these neutral particles had a mass of 1.675 into 10 to the power negative 27 kilograms. If you might have remembered from this is almost equal to the mass of one hydrogen atom, or you can say this was the mass of proton, right? So it was almost equal to, it was little bit heavier as compared to proton, but it was almost equal to the mass of that proton. But as proton had positive charge on it, it had no charge on it. It was neutral. These neutral particles, okay, these were neutral particles. They have been given the name neutron. Okay, these were neutrons. They had the mass of 1.675 into 10 raised to power negative 27 kilogram, and they had no charge on them. They are electrically neutral, though they did not have any electrical charge on it. Okay, those are called neutral particles, neutrons. So let's talk about the chemical reaction which actually happened in this particular experiment. In this experiment, what he did was he took beryllium, okay, whose atomic mass was 9 and atomic number was 4, and then bombarded them with helium or alpha particles, right? And they got carbon atom and neutron atom. Okay, you can see that masses will remain same, because according to law of conservation of mass, whenever a reaction occurs, the mass of the reactant should be equal to mass of product. We are talking about law of conservation of mass. Right? According to it, total mass of reactants should be equal to total mass of products. So in the above reaction, it should be true, right? We have beryllium and helium in the reactant, and carbon and neutron in the products. Reactants, beryllium has mass of 9, helium has mass of 4, and carbon has mass of 12, neutron has mass of 1. Both of these comes out to be equal to 13 atomic mass units. So according to that, the masses are equal in this particular reaction. So this is how the neutrons were discovered. Now let's talk about the definition of neutron. Definition of neutron. Okay, a neutron is a subatomic particle. It is obviously a subatomic particle. That has a mass of 1.675 into 10 to the power negative 27 kilograms, which is equal to the mass of hydrogen atom, and it is electrically neutral. It does not have any charge on it. So that is the definition. Now we know that atom is not the smallest particle. It has some other subatomic particles also, which are three subatomic particles. First was electron, then was proton, then was neutron. We got to know a few things. The electrons has one negative charge, protons have one positive charge, and neutron have 0 charge. The mass of electron is 9.1 into 10 to the power negative 31 kilogram. Proton is 1.67 into 10 raised to power negative 27 kilogram. And for neutron is 1.675 into 10 raised to power negative 27 kilogram. Okay, we got to know about these things right now. Till this date, we got to know that this is the true about these subatomic particles. So these were a few subatomic particles which are important for us. Now, because of the discovery of these subatomic particles, what happened was that new atomic models were, discovering along with them. They came into existence. Different people were working on them, and they got to know that Dalton's atomic theory was not only the single atomic theory which is correct. Now there are other people, those who were giving different atomic theories. So let's talk about them. Now, as you know that various people were working on different atomic theories, there was the first atomic theory which came into existence, and that was Thomson's model of an atom. If you have done science in class 9th, you know that this model was also discussed over there. So Thomson model was actually given by same J.J. Thomson, who was the discoverer of electron. So what did Thomson model proposed? J.J. Thomson proposed in his model that an atom is a spherical cloud of positive charge, and electrons are embedded in between these spherical charge randomly. Okay, it was just like a raisin pudding. It is also given over here, or plum pudding. It is also known as watermelon model. Right? So this actually gave us an idea that, you know, an atom was spherical. Okay, it is not two-dimensional, it is three-dimensional. One thing, it was a 3D structure, and it has positive charge. Now you might ask that how these positive charge and electrons are equal. So he gave only one thing. He said only one thing, that the magnitude of positive charge, okay, magnitude of positive charge is equal to magnitude of electrons or negative charge. Right? This is how an atom was electrically neutral. Okay, so this is what he said. But soon it was discovered that this is not correct. His one of the co-worker, known as Rutherford, actually performed an experiment called alpha ray scattering experiment, or alpha scattering experiment, and through which he proved that the model given by J.J. Thomson was wrong. So our second model of an atom is Rutherford model of an atom. So let's talk about it. Rutherford actually took a source of alpha particles, and alpha particles were made to strike on metal foil, especially gold foil, due to which this particular experiment is also known as gold foil experiment of Rutherford. Okay, so he took very thin gold foil, and he made these alpha particles to strike on the surface of gold foil. What happened was that maximum alpha particles actually went straight. Okay, there was actually fluorescent screen, okay, semicircular or circular fluorescent screen was there, and this whenever these alpha particles they strike with the screen, they actually glowed. Okay, they show a glow. Okay, they showed a faint glow or any kind of glow. So what happened was the maximum alpha particles actually traveled in the straight line. Okay, they were undeflected particles, and there were few which were deflected particles, very few. And 1 out of 12,000, okay, 1 out of 12,000 alpha particles were actually bounced back at 180 degree. So it was like that. There was an atom of gold, okay, and most of these alpha particles were undeflected. These are undeflected. A few were deflected at certain angles, okay, a few were deflected, okay, and there was only 1 out of 12,000 which was deflected back. So these were the observations of Rutherford's gold foil experiment. So from this experiment he got to know few things, that see, the alpha particles which we are talking about, and we have already studied about the properties of alpha particles. Alpha particles are helium ions which are too positively charged. Okay, that means they had a positive charge on them. Fine. If these alpha particles, and these alpha particles are quite heavy also, because they have a mass of 4 unit, that's quite more. So these have two things, they are heavy, along with it they have positive charge on them. And from the electrical theory of charges, we know that Coulombic charges, if they have same Coulombic charge on them, the same charges repel each other and opposite charges attract each other. Okay, similar with the negative charge also, negative charges repel each other. So as helium particles are positively charged, when they are deflected, that means they are repelled from somewhere, and only charge which can repel them is a positive charge. So in these atoms, in the center, the exact center of these atoms should have a positive charge on them. Okay, from where around from where they are showing small deflections, okay, or large deflections, or even the back scattering or bouncing back on the same direction. Most of them are undeflected, right? A few of them are deflected. And why they are deflected? Because these atoms has a positively charged substance in them. One more thing you have to remember, they are only deflected back when that particular positive charge should be heavy enough to bounce back this heavy alpha particle. Okay, so he got to know a few things, that an atom is almost empty, but in its center there is a positively charged part, which he later on called nucleus. Okay, and around it the space is empty. Okay, this is how an atom is present. One more thing you have to remember, nucleus is quite heavy. Okay, and he also knew about the discovery of electrons. So he told that these electrons are actually revolving around this nucleus, just like our planets are revolving. So he used the Kepler action, like the positively charged nucleus, around it electrons are revolving, and electrons are revolving as the planets are revolving around sun. So planets are revolving around the sun on a fixed path known as orbits. So these electrons are also moving in a orbit. Okay, this was Rutherford's nuclear model. Rutherford's nuclear model. Although Rutherford's nuclear model was quite advanced as compared to J.J. Thomson model, but it actually had a few flaws. So there were limitations of Rutherford's model. Okay, let's talk about it. So in the limitation, actually what he could not explain was that how electrons are moving around the nucleus. So before that we were talking about there was a scientist known as Maxwell. He actually proposed a theory, and according to his theory, what was there that whenever an electrically charged particle is moving in a circular path, it will always radiate some energy. Okay, due to radiation of this energy or radiation of any kind of radiation, the electron is actually slightly passing and getting attracted towards the nucleus, as a result moving in the spiral path. And if it happens at the end, this electron should fall into the nucleus. And if it happens, then atom should never exist. So existence of atom was a question mark according to his theory. He could not explain existence of atom. He could not explain the stability of an atom. Okay, according to Maxwell's theory, the electron should lose energy and radiates energy. If that happens, then electron should be attracted towards the atomic nucleus, and if that happens, then at some time, this electron should fall into the atomic nucleus, thereby questioning the existence of the atom. So this was the major limitation of Rutherford's model. And that brings us to the end of today's session. I hope you have understood the concepts and also gained the confidence if there is some question asked from this particular topic. Always remember, chemistry is easy, but when you focus on the concept and alongside you practice consistently. Thank you so much for watching. Keep learning, keep practicing, and as always, keep ascending. See you in the next video.